Hi everyone, in today's video we will try to solve number theory problem. The problem statement is that the n, which is natural number, which is equal to 1 to the power 4 plus 2 to the power 4, and this continues till 2011 to the power 4, and that it is asked that what is n when we just find mod with respect to 16. And first of all I want to explain what does this mean, and we are asked to find what is x equal to. Let's talk about division operation. We know that there are we can write that first term written is dividend divided by divisor, and it will be equal to our result, and we will have sometimes a remainder part. Let's just write an example for this. 15 divided by 4 will be equal to 3, and it is 12. 15 minus 12 will be equal to 3. And also I should mention that remainder is always less than divisor. And this x here represents the remainder in our equation. We just want to ask that when n divided by 16, we have some result term here, and we will have some remainder which is equal to x in our case, and we should find what is x equal to. And we talk about 16. As we know, 16 is equal to 2 to the power 4, which means that if we have this term in some part of this expression, we can just eliminate them, because when it is divided by 16, the remainder will be equal to 0. Therefore, we have some here the even numbers. For example, 2 to the power 4 plus 4 to the power 4 plus 6 to the power 4, and this continues till the end 2010 to the power 4. And all of them contains the 2 inside them. Let's just take 2 to the power 4 out of the brackets and write the expression again. It is equal to 1 to the power 4 plus 2 to the power 4 plus 3 to the power 4, and it will continue till 1005 to the power 4. And let's just try to continue, and when we divide it with 16, and this will be eliminated, and we will have a result, and in this case remainder will be equal to 0. Let's continue with the remaining terms, which are only odd numbers, and try to arithmetically just analyze them. What do we get when our number is odd, and then we just use the power 4 for them and try to find their result in mod 16. What will be our result here? 1 divided by 16, our result is 0, and remainder is 1. 3 to the power 4, it is equal to 81, and when we divide 81 by 16, the result is 5, and remainder is again 1, mod 16. And let me just assume that always our remainder will be equal to 1. But how can we prove this? Let's just go into a little bit deeper and try to prove it. All the odd numbers can be shown in the form 2n plus 1, and when we just use the power 4 for all the representation of all odd numbers, we can write this term here. And I just assume that always this number will give us 1 in mod 16, modular term 16. And for just prove this one, I will use binomial distribution theorem. Which states that a plus b to the power n can be written in this way. All the combinations from n to 0, a plus b to the power n, and a to the power n, and b to the power n minus 0, plus all the combinations from n 1 to 1, a to the power n minus 1, and b to the power n minus 1, and here it should be 0, b to the power 1, plus again the same way, just power of n will just go down 1 by 1, and power of b will increase in the same manner. And this will continue till all the combinations from n to n, and we should write a to the power, here it will be 0 because at the beginning b was 0, and b will reach its maximum n. And this is the just formula to distribute the this kind of terms. And as you see, our n in the case is 4, a is equal to 2n, and b is equal to 1. And let's write the same formula for this expression. 2n plus 1 to the power 4 is equal to distribution for 0, 2n to the power 4, 1 to the power 0, plus binomial distribution for 1, it will be 2n to the power 3, 1 to the power 1, plus, actually we can just eliminate these 1 terms because they will not affect the result at all. And the third one is n2, n is 4, 2n to the power 2, again I will not write for 1, and this is 4, 3, 2n power, it will be 1, and the last one is 4, 4, and 2n power 0, 1 power 4, and it's just 1. Let's just open this expression. All the combinations can be found 4 factorial divided by 0 factorial multiplied by 4 minus 0 factorial, which is in our case is equal to 1, and 2n to the 4 is equal to 16n to the power 4. And this is divided by 16, therefore we will not have any remainder. We can just eliminate this term. For second one, 4 factorial divided by 4 minus 1, 3 factorial multiplied by 1 factorial, it will be equal to 4, and 2n to the power 3 is equal to 8n cubed, n in cube. And 8 multiplied by 4 is 32, which is divided by 16, and therefore we can eliminate this from here, because finally we will not have any remainder that will be the result of this term. And for third one, let's write 4 factorial divided by 2 factorial multiplied 4 minus 2 factorial. It will be 24 divided by 2 multiplied by 2 is equal to 6, and this term is equal to 4n squared. When we multiply them, we will get 24n squared. And right now we don't know whether this term will be divided by 16 or not, therefore we just keep it for now. And for the fourth one, 4 factorial divided by 3 factorial multiplied by 1 factorial, actually this is the same as combinations from 4 to 1, and it's just equal to 4, and 2 to n to the power 1 is equal to 2n. 4 multiplied by 2n is equal to 8n. Right now we also don't know whether this is divided by 16 or not. And write it for the last one. 4 factorial divided by 4 factorial multiplied by 0 factorial, 4 minus 4 factorial is equal to 1, and 2 to the 2n to the power 0 is equal to 1, and we have one term right here. And we should just, in order to get the 1 from the result, we should prove that 24n squared plus 8n plus 1 will give us 1 in mode 16. When we divide by 16, our remainder will be 1. We should just prove this one. For now, I see the same terms inside the first and second part of this polynomial function. Let's just put 8n out of the brackets and write the expression for it. Plus 1 give us 1 in mode 16, which means that this term is fully divided by 16, and as a reminder we get 0. And you can just see that we have 8 here, and in order to make this term fully divided by 16 we need one even number, because each even number contains 2, and when we divide, remainder is 0. And if this number is even, always this number will be odd, even, odd. But if this number is odd, this number will always will be even. Therefore, in every case we have even number in our expression. Therefore, we get 16, and this expression is fully divided by 16. And we proved that each fourth power of each odd natural number will give us 1 in mod 16. And let's just go back to our first initial problem, and we had to just find that 1 to the power 4 plus 3 to the power 4 continues till 2011 to the power 4. What will be our x in mod 16? We know that each term here seen in this full expression will give us 1 in mod 16. How to find the number of terms? We should just subtract first term from the last term. This one divided by the difference between terms. For example, 3 minus 1, 2. And at the end we should plus 1, which will give us 1006. And to just our problem was simplified to 1006 in mode 16. And this is very easy problem actually. Let's just divide the 1006 by 16. This will get 6 minus 9, 6, and 46, which is equal to 2 minus 32 and 14. Our remainder is 14. We found the final answer, and this is correct. And you can just use this theorem, this binomial distribution theorem. You can solve so many Olympiad type questions. And this is the end of video. If you like this video, please like, comment and subscribe to my channel.